Normally, after stepping into something in debug mode and seeing it, typically the next step is to say debug, stop debugging, just say, don't worry about it. I saw what I was supposed to see and I'm done. So you're throwing this debug session away and going back to your normal coding. So back to the original challenge. Stack push, right? Because right here now I have this integer which I can use as an index, right? So now instead of hard-coded 0, I can say top of stack as promised, right? Top of stack right here now tells me which element to access, which one of these elements to access at any given time. So therefore, I can say push and use top of stack, which initially is set to 0, which points to the first element of this memory block array of integers. But then, of course, immediately I need to say plus plus top of stack, so that the next time someone calls push, the top of stack will be already incremented and will be pointing to the next available element. So my top of stack, from the very beginning, even when the stack is still empty before the first push, the top of stack always points to the top of the stack, right? It always is an index of an element which represents the element which is available to be used, right? So the first time when let's just go back to our demonstration, right? So just say push 11, 22, and push 33. Well, like 3 elements. If that happens, right? If that happens, what should be stored in memory is, of course, this. This is going to get 11, this is going to get 22, this is going to get 33, and top of stack with every push gets incremented, so it becomes, it is 0 to begin with, it then becomes 1 and stores 22, gets incremented, becomes 2, and when I store 33, it actually gets incremented and points, gets value of 3 and points to the next available element. Now, my immediate observation is that if you look at function size, at the beginning, top of stack data member of my stack object is 0, and the size is also 0 because no one stored any elements in my stack object. But when they say push, the top of stack gets incremented and becomes 1, and the size is 1. But then the second time push happens, again increment happens, and top of stack will say 2, and that's exactly the size. So perhaps implementation of the size is simply this: return, right? Return top of stack integer, right? If I just return the value of the top of stack, so far it indicates the number of elements. 0 to begin with, 1, 2, 3, 4, 5, and it progresses as more push events happen as a result of this main, doing the push, storing the value, and incrementing the stack pointer. How about pop? Pop is not supposed to return anything, and pop doesn't take any values. So therefore, in my view, all I need to do is just basically return the top of stack to the previous position. So if push said plus plus, which means plus 1, the pop simply should say minus minus. So implementation of pop is quite trivial, I think. Really is really trivial. And finally, the top simply should go to the memory block, right, and return, right? So if so far I had stack push 11, right? Then I said stack push 22. then I said stack push 33, and if I say stack top, in whatever context I want to make this call, it has to return this value. Basically, the top promises that anytime you say what's at the top of the stack, it should return the value at the top of the stack. That's what it's supposed to return. Okay? So again, it seems like top of stack is going to be a tremendous help in the implementation of the top. So if I simply say return memory block top of stack, right? If I say instead of hard-coded 0, which was there just to get started with something that looks like compilable code, but now if I say return memory block top of stack, it's probably halfway done, because what happens is that I am about to return whatever the top of stack says. But remember, whenever the element is stored like this, the top of stack is always pointing to the next available element. So if I simply say return memory block with index top of stack, I would be returning this question mark, right? I don't want to do that. Therefore, it sounds like I simply need to say -1, right? So -1 would be the right index to use with memory block to say go to that specific location, and that's where the top of stack, really the top element is located, which is stored there. By the way, using the code like this, right? So if I created the stack and the stack is empty, and if then I said top of stack and tried calling top of stack, right? So the stack is empty, right? So the top will be invoked, and the top function is right here. The top is invoked. 0 minus 1 is -1, so this will become -1, and memory block with index -1, of course, will be attempting to return something from potentially illegal memory location in front of the first initial element of our stack, and this may actually crash the program. So let's try this. Build, right? So now with main containing this innocent looking cout statement, but calling top with an empty stack. So we say debug, by the way, let's just get rid of this breakpoint just to see if it even runs and what the behavior is. So we say start debugging. Well, in my case, the program didn't crash, but it showed me memory in this index -1, which is located earlier than the initial element, and I still had access to that memory, and it printed this garbage value, right? Minus 85, 89, 93, whatever, right? And that's just garbage, right? But it wouldn't be a big surprise if in a different circumstance this was an attempt to access memory which may not belong to me, because remember, all of this is happening someplace, and let me try like different. This happens someplace inside the legal boundaries of my stack frame that main function has access to. So this thing here may be well outside of the boundaries of that stack frame. Who knows? And if this happens, then things can be, the program can crash because of the memory access violation and so forth. All right. So anyway, so this is, of course, a big no, and how to deal with this is our choice. We can simply write documentation and tell the users, look, don't attempt this. If you want to access the top element and your stack is empty, then you'd be in trouble, because the behavior is unpredictable. okay? It may crash, it may not crash, it may produce a garbage value, or it's completely unpredictable. End of story, okay? So the user has to be kind of careful with attempting to use the stack, and make sure if they want to access some elements, they have to first populate the stack with some elements. Okay, but this is our first attempt to implement the stack. Let's see. So we have the constructor, which is invoked when the object is created. The constructor populates using the initializer list. The constructor populates the important data member inside the stack, right? This important top of the stack populates it with 0, guarantees that it's 0 to begin with. Then we have the push, which essentially points to the right location in this memory block and stores the value in there, and increments. Basically, the comment here could say stack maintenance. Maintenance, right? And likewise, the stack maintenance happens over here as well, right? So push and pop do something to maintain the state of the stack. By the way, when we use pop, right? When we use pop, and basically, you should note that when we say, now let me go back to where I was. When we say pop, essentially top of stack gets its previous value, right? So the top of stack, essentially, if we pop all of the elements, the top of stack will go back to 0. But notice that the old value, like 22 and 23, remain in memory. They're just not, we're not trying to attempt them, and essentially they're not recoverable, right? There is no interface, there is no means by which we can go back to 22 and 33 and retrieve these values from the object. They basically remain as garbage. Right, so this remains there as garbage. Those are just remnants of some prior uses. But if we say push again, those values will be overwritten with brand new values.